HMO diversity impact infant microbiota activities. This was tested in an ex vivo fermentation system. My name is Florence Rochat. I'm working at the Nestlé Research in Lausanne, Switzerland. Why we are interested by the HMO diversity? We know that breast milk contains a large number of human milk oligosaccharide, what we name HMO, and they are grouped in three main categories. We have the core structure with the LNT, LNNT, and we have also the fucosylated type of HMO, like the 2FL, DFL, and also the sialylated structure with the 3SL and 6'XSL. These different HMO were reported from the last century to promote specifically the growth of bifidobacteria. And this is related to some health benefit. We know also that diet is a main driver for the modulation and impact on the gut microbiota. So there is a lot of studies showing that in addition of the 2FL or 2FL in combination with LNNT to infant formula, there is impact on the microbiota and impact on the immune system and gut health. But what about a more complex mix of human milk oligosaccharide, HMO, and what about the impact on the ecosystem and the metabolite of the gut microbiota? This is what is of interest for us now. So the objective of our study was to test the lactose as a sort of control, the 2FL, the mix of 2FL and LNNT, and a mix, more complex mix of 6 human milk oligosaccharides that we know today how to produce them. So the microbiota composition were tested, as well as the production of short-chain fatty acid, the branch chain fatty acid, ammonium derivate, and other different parameters. And we test this in 2 different ex vivo intestinal models. I will be back on this in a few seconds. And we follow, as I said, the microbiota and the metabolite. This was done in with the HMO model in collaboration with ProDigest. So to test these microbiota with the different HMO, so we use a short-term fermentation model. So you have the picture here, using baby fecal sample with five breastfed infant and 5 formula-fed infants, so sequentially. And we test the different mix of the HMOs. And we were using also the long-term named HMO. So this is a 3 weeks model. So here is the picture. So this is a much more complex system where we can follow really the ecosystem on the long-term long-term effect and impact. What we observe, in fact, this is the impact on microbiota, and you can see here, this is on the long-term effect as example, that we have a certain effect with the lactose, but with 2FL, LNNT, and the mix of 6 HMO, the effect is much more pronounced, and this is observed in the proximal colon and also in the distal colon. The major fact that we have to retain, this is that we strongly impact the actinobacteria phylum and family, and more concretely, the bifidobacteria, and we reduce the firmic death. Interestingly, with the mix of 6 HMO, there is a particular benefit on Faecalibacterium prosnitzi. And this bacteria is known more and more to have beneficial effect. And this is really true with a mix of 6 HMO. You can see here, this here. With 6 HMO, over the time, over the 3 weeks, we see a pronounced and significant increase of this Faecalibacterium prosnitzi, which is known and described now in the literature to be beneficial and exert some anti-inflammatory effect. It is known to decrease the colonic sensitivity and restore the balanced immune system. So this is really interesting fact. Now, if we are looking more on the functionality of this microbiota, so here, as I said, you have the impact on bifidobacteria, more pronounced with a mix of several human milk oligosaccharide, but you have also an impact on different metabolite. For example, we reduce the pH, and there is also a promotion of acetate, of propionate, particularly with the human milk oligosaccharide, and also on the butyrate. We have observed also an interesting impact on branched chain fatty acid, which is a decrease, and particularly with this mix of oligosaccharide. Now, if I continue and show you some specific details that we observe in the short-term batch model and also in the SHIME, we observe that particularly with a mix of 6 HMO, we have a promotion of butyrate during the fermentation. And this is on the opposite. We have a decrease of branched chain fatty acid with a mix of 6 HMO more pronounced. And this is interesting because this is a marker of proteolytic activity that we want to reduce on a benefit of saccharolytic activity. Finally, I just want to show you this interesting data. This is on the speed of the use of human milk oligosaccharide by the intestinal microbiota, always observed in our model. And we can see that when we are adding more oligosaccharide, the use of these oligosaccharide is much more, the speed is higher compared when you have single or only two oligosaccharides. So more oligosaccharide you add on the system, more the use of these oligosaccharide is efficient. And this is true for the 2FL, and this is also true with the LNNT. So also the this is an only simplified model with single microbiota each time. This indicates that the microbiota react differently and on the dynamic effect with the HMO diversity, and this is more you increase the number of HMO, more you observe a reaction of the microbiota and the metabolite. Thank you.